All right, so back again now for part two. In part two, all we're going to do is say that we can get an exact solution if we go to a limit where delta theta goes to 0 of this expression right here. Okay? Delta E hat 0 theta pi over 2. Yeah. And in that limit, these Riemann sums turn into integrals. So I still have lambda all over 4 pi epsilon 0 r, but rather than multiplying it by two summations, this is going to turn into I hat, the integral from 0 to pi over 2 cosine theta d theta. This is going to turn into j hat, the integral from 0 to pi over 2 sine theta d theta. All right. And now if I come up here to execute these two integrals, like I said, you've done this before many times, I'm sure. Cosine theta d theta turns into sine theta evaluated from pi over 2 to 0. Sine of pi over 2 is 1, sine of 0 is 0, so this is 1. Second integral, pi over 2, 0 to pi over 2 of sine theta d theta is equal to minus the cosine of theta, also evaluated from 0 to pi over 2, minus the cosine pi over 2 to 0 is the same thing as cosine 0 to pi over 2. Cosine of 0 is 1, cosine of pi over 2 is 0. So both of these integrals turn out to be 1. And then if I take that and put it back down into this expression, we wind up with our final answer, and that is E exact is equal to lambda all over 4 pi epsilon 0 all over r I hat plus j hat. Yep. So again, I don't think the calculus added very much here. I think the process by which you arrive at the calculus formulas, I think that's a little bit worthwhile. All right, very good.